Hello, everyone, and welcome to this week's Cassandra Community webinar. I am delighted to present today Mick Weaver from Fin.no. Fin.no, for those of you in the States, think of it like the Norwegian equivalent of Craigslist, and Mick is a senior software engineer there. And Mick has been a tremendous supporter of the Cassandra community throughout Europe. He has participated in meetups, and he at the London Cassandra Summit last year. So Mick, we really appreciate your support of the Cassandra community. Very excited to have you with us today. And if you would like to ask Mick a question, we will hold all the questions until the end of the webinar. Please type them into the Q&A tab inside of WebEx. So without further ado, let me hand over to Mick.
Hello, everyone. Thank you for a warm introduction, Christian. My name is Mick, and I work at Fin.no, and I've been asked to give a presentation about how we do fraud detection at Fin.no. Fin.no is Norway's busiest website. Hang on a second, I should share the desktop first so you can see. There we go.
Okay, Mick, we can see it well now.
Thank you, Christian. So Fin.no is Norway's busiest website, and it is a classifieds website. It is the predominant classifieds website over a very broad range of classifieds. So here we're talking real estate, jobs, bits and pieces like trading post or eBay, cars, boats, motorcycles, travel services like cheapest flights, cheapest hotels, and personal and professional services. The only other website in the world which has such a broad range of categories, all in one website, and is the predominant player, is in New Zealand. So you can see for us that dealing with fraud detection is very important. A little bit about myself. I've been at Fin for about 4 or 5 years now. Most of my time has been spent working with the core platform. And I've also, along with some colleagues, helped set up our big data platform, primarily Cassandra Database. Fin, in its first 9 years, was working with a Java monolith application built on top of Sybase. In 2009, they saw that this was starting to become a problem, and they started to modularize the code into a service-oriented architecture. This, in my opinion, is where things got really interesting. We started to see a platform built up of Thrift-based microservices, and it was the beginning of our polyglot assistance model. One of the first modules that we took out was to deal with the statistics, and there we used Cassandra to collect all of our events, and we used Hadoop to aggregate them into the statistics that we wanted to show back to the owners of the classifiers. What we found afterwards was that Cassandra is a fantastic database which can be used for a lot of other simpler use cases. And so today, when people come to us and they say, hey, we're writing some new code or we're redesigning some old code, do you think that Cassandra is the right choice? The questions that we ask back to them along these lines. Do you have a high or fast write throughput requirement? If you do, then Cassandra is the right choice for you. Can you see yourself benefiting from a schema-free design? If you're doing the SQL data model and you're finding that you're using joins, or if you see that you have sparse data or that you'll have growth in columns as much as you'll have growth in rows, again, Cassandra is going to be a better choice for you. Another reason to choose Cassandra is time to live on data. This is a really fantastic feature of Cassandra. It's especially useful when dealing with big data and when you're wanting to collect more and more data but you don't know yet if it's of value. You can store it for just short periods of time and it will disappear by itself. But it also has a lot of value in simpler use cases as well. And it can help simplify your code because you're no longer writing code, having to maintain that code, and having to run separate batch jobs to clean up the data in your databases. Another aspect is about scaling out. If you have a requirement of the size of data or the total load, or you have a requirement on uptime, which you don't trust on one node, then Cassandra again is the right choice. You don't want to be scaling out your SQL databases, you want to be scaling out Cassandra. The last point on the list is being able to tune between consistency and availability. And this really comes down to getting developers to properly understand the CAP theorem, to be making a conscious decision between availability and consistency early on in their design, and also to be understanding that the business that pays for their salary often values availability in a lot of use cases over consistency. It's one of those situations also, if you properly implement availability from the beginning, you'll find that you end up with simpler code. So for us, at Fin, our Cassandra cluster is quite small. We're not Netflix or Amazon or eBay. And we also don't run commodity machines. So our hosting provider only gives us quite beefy machines. So our Cassandra cluster is of just 6 nodes spread over 2 physical data centers. 4 of those nodes are paired with Hadoop. Like I mentioned, the first use case worked with both Cassandra and Hadoop. And we have 2 extra nodes which don't have Hadoop sitting on them. That's because our Cassandra cluster needs to also be serving requests with a latency low enough for web applications. And we tackle that by creating 4 virtual data centers. So that each node that doesn't have Hadoop sits in its own virtual data center. Well, the normal recommendation here is to have a completely separate data center just for analytics, where Hadoop lives, and not let your web applications talk to them at all. Here, because we don't have yet a big enough cluster, we let our web applications talk to all 4 data centers. We find that 99% of the time, even the Cassandra nodes with Hadoop sitting on top of them operate fast enough for the web application. So we have those 2 extra nodes without Hadoop as a guarantee. So that's our setup. Moving forward to fraud control, which is the topic of the talk. Fin gets about or up to 10 million classifieds a year. And for us, the position that we're in, we're a high quality website. You can think of us as being at the opposite end of the spectrum to Craigslist when it comes to quality. So it's important for us to maintain a high reputation and a high level of trust between both buyers and sellers. So we put a lot of effort into fraud control. And we were having to check around 55% all of those classifieds entered. This was just to tackle around 30 fraud ads each week. Around 70% of them we were detecting before they got published. A quick overview of the life cycle of a classified. When a user enters the ad pin, it comes in under a started state. From there, it goes to the fraud control system. The fraud control system, through either an automated process or a manual checking process, makes a decision about the ad. That can be that it's marked as invalid, that is, it's missing information, or it's not meeting requirements. Here, the ad is sent back to the author. They have a chance to edit it and submit it again. The ad can be marked outright as rejected or fraud, or of course, the ad can be accepted, it becomes active, and is published on the internet. From there, an owner can pause and resume the ad at any time. They can mark it as sold, or after the period of time for which they're paid for goes out, the ad will become expired. The fraud control or the customer center can also step in at any time, often related to tips from the public, and mark an existing active ad back as fraud or invalid. And of course, if an owner edits an ad, it starts the life cycle again, and it needs to go often through the fraud control system again. So inside the fraud control system, we have like an expert rules system. So we have a set of rules which are applied against each ad. The scores from those rules are weighted together. And depending on the final score, a decision is made. A low score will result in the ad being automatically published. The middle range score will result in the ad going to our outsourced manual fraud control. And a high score means that it goes to our in-house fraud control. A more complicated diagram for this process. You can see that when an ad is entered, it comes into the fraud control system and it's given an ID that's based on the ad's ID and the timestamp of the change. The rules are applied and recorded against that ID. The decision is made, published, so it ends up as published, invalid, or rejected. And for the published ad, if they're edited by the owner, it goes back in. So then the second time when it gets scored, it gets scored under a new ID because the timestamp changes. So that wraps up a brief introduction into the fraud control system. Next, I'm going to dive into the data model we use in Cassandra for storing the scores. Not all of this will make immediate sense to you. So give me a bit of have some patience with me, give me a chance, because I will explain it in more detail after I go through the data model. So to begin with, we have two tables in Cassandra. We have an ad created table and we have an ad status table. They're both really simple. And the point of this presentation wasn't to give you an advanced Cassandra data modeling exercise. It was to show that even with quite advanced domains, when you implement them in Cassandra, they're very simple. So with our two tables, ad created table, we have for each day, or even each day and hour, we collect the timestamp and the ad ID combination, and with that, the map of rules and the scores. In the other table, we collect for each ad ID, each time it's changed, a timestamp, and the status or the new life cycle status it took. How does the application read this data? First of all, it reads periods of time. So here, we're not so much worried about what were the scores for an individual ad, because that's something that happens immediately in the code and is dealt with. Here, this data, we're interested in looking at how the export rules system is operating over periods of time. So the first select statement we do is, for a given day, get me all of the ads which have been calculated and all of the rules and their scores. From that list of ad IDs, get me all of the status changes which have happened. When we write the data, it's also quite simple. When the ad comes into the fraud control system and the rules are run against each ad, we write that directly into Cassandra. And this data we're only interested in keeping for 1 year. Each time an ad changes status in its life cycle, we also record that into the other table. Now, of course, we don't write our SQL directly. We use the SQL driver from DataStax, which is a fantastic addition to Cassandra. So for the first select statement, we use the query builder with 4 method calls. For the second select statement, again, the query builder with 4 method calls. For our writes, you see that it, again, is very simple Java code. What's wonderful here, and I think it's a common misconception about Cassandra, people think that Cassandra is a very complicated piece of software. And under the cover, it kind of is. But Cassandra, over the last couple of years, has become remarkably simple and easy to work with. And that's the point of these 2 slides. The Java code that's up on the screen shows how easy it is to work with Cassandra. Lastly, to deal with the data model, let's have a look at the operations. To begin with, we keep a replica of this data in each of our 4 data centers. And because we don't need strong consistency, all the read and write operations are done with consistency level 1. For both reads and writes, we have fantastic performance. Writes average in at 25 microseconds, and reads average in at under a millisecond. Not only do I think that you could not have such a simple data model if you had done this with SQL, I don't believe you'd get the same performance as well. if you haven't already installed Ops Center and DataStax, I recommend that you do. It makes running a Cassandra cluster a lot more fun. Here I've taken a screenshot from both of these tables, and you can see that that performance is not just fast, but it's very consistent over time. You can also see that there's very little variation in performance across the nodes in the cluster. That's important when you relate it back to our cluster and how 4 of those nodes have Hadoop sitting on them and can at times have many jobs in Hadoop and really be trying to bring those Cassandra nodes down to their knees. Still, fantastic performance for other applications running on top of Cassandra. Okay, hopefully you've bared with me through the data model. I get a chance now to explain a little bit better of how that data model is used. In our admin system, we have a dashboard which shows over periods of time how the rules are working. So here you see on the left-hand side the different rules that we have. And you can see for each rule how many times they get triggered. And for the ads that they get triggered against, you can see with those ads manually rejected, and manually marked as fraud, automatically accepted, and manually accepted. And most important is the 2 last columns on the right-hand side, where you get to see the ads which got published but shouldn't have. And so those numbers represent published ads which got changed back to a fraud state, or published ads which got changed back to a rejected state. You can see from this, not only does it give a very valuable insight into how the rules are performing and help us edit the rules. Inside each rule, there are many variables and conditions, but it also paves the way for machine learning and supervised learning. We can start to see what we want out of the system. So as you start to introduce machine learning, you're going to want this type of insight, and you want to be able to. You're going to want to be running an A/B test over a period of time. So this takes us to machine learning. And machine learning is something at Fin which is still very new for us. We're very fortunate that we've had a number of very bright minds push enough for it that we're starting to see more of it come out in production. One of the first things that happened was we applied logistic regression learning onto the rules to find out what was the best weighting between the rules. When we did that, we saw quite a dramatic change in the ads that were automatically detected. In this graph, the blue line shows the total ads coming into our system. The green line shows ads being automatically accepted and published, and the yellow line shows those having to be manually checked. You can see previously we're having to check around 55% of the ads. After we put into production the logistic regression learning, that dropped down to 20%. And on top of that, about 10 to 15% of that is ads that we're forcing into the manual checking process to ensure that we get a randomness of ads coming through into subsequent machine learning processes. Now, hopefully you can see from this graph just how much value we got out of this. There's a lot of money involved in being able to not have to manually check so many ads each day. And of course, we can start to apply machine learning to other parts of the system as well. We would like to start analyzing all of the ad data, not just using the rules. And to do this, the fraud detection team have created an in-house machine learning competition, Kaggle. So this is lots of fun for all the developers here, and it allows us to play and test lots of different alternatives. It will probably turn out that we will go for, or the winner will be, a random forest and decision tree approach. Indeed, you're seeing papers published in the industry around fraud detection and classifieds recommending random forest approaches. Other things that we're seeing as we start with machine learning is we have a need to log more. You have no idea about where the next attack is going to come from. You have no idea what the trend of the fraudulent actors will turn into. And for this reason, you really want to be collecting as much information as you can around the classified. And there is no better tool to do that than Cassandra. Just like our statistics system, where we're collecting events on all of the user's behavior so that we can show statistics back to the owner of the classifieds. Again, Cassandra is a very effective way of collecting information and then processing it later. Another interesting aspect of machine learning is around A/B testing and whether A/B testing is good enough. One of the problems with A/B testing is it's built upon the premise that every A is an incremental improvement over the previous A. And the problem here with fraud detection and classified is that the ground data is live. It's constantly changing. The environment is changing. The fraudulent actors are learning and adapting as well. And so this makes it very difficult to know, is this new algorithm superior just in this period of time, or is it generally superior? For example, you may see trends just with the season. You may see one type of fraudulent activity during the summer and a different type of fraudulent activity during the winter. This is just an example. It's an example that highlights the case of where A/B testing could get you into a loop, just like a dog chasing its own tail. It's better to take a more complicated look at A/B testing or multivariate testing. You have different training sets of data. You have different algorithms to test continually. When you start to see the need for that, you start to see the need for a better machine learning platform. And this moves on to the next point, in that when your ground data is live, you also want to have automated machine learning or online learning. It becomes a cumbersome process of having to run manual batch jobs to grab data from this database or that database and put them into CSV files and clean up the data, which a lot of time is spent on doing, and then feeding them into a manual learning process and then putting the results in production. You really want to automate as much of this as you can so you can rerun it every week or two, so it stays up to date with your changing environment. Again, you're starting to see the need for a better persistence model underneath your machine learning practices. And Cassandra is a good choice here. So this about wraps it up for me. First of all, I'd like to give a very special thanks to the bright minds which are working on this at FIN. I'm not working with fraud control. I just get to talk about it, make it sound like I am. So special thanks goes to Ricardo, Christian, Thomas, Anders, and Adil. And of course, at FIN, we're always hiring best minds in the field. So if you're talented on Cassandra and on machine learning, you would like to live in Oslo, or you do live in Oslo, please do get in contact with us. The point of the presentation was to give you a run-through of Cassandra and some data models that we have in production, give you some experience of our Cassandra setup, but also to show that while machine learning in theory can be simple, when you start bringing into the picture ground data, which is live, changing and adapting environments, the need for faster online learning, bigger matrices of testing, then it makes machine learning a rather challenging field. And you do need to have a solid NoSQL persistence layer to deal with it. So that wraps it up for me. I believe we have time for questions now. Hopefully I can answer all the questions. Of course, this is a sensitive area to FIN, so there may be questions that I can't answer. But fingers crossed, I can answer all the questions. So back to you, Christian.
Thank you very much. So you can ask questions, but it sounds like Mick might have to kill you if you do. So a couple of upcoming events while we are receiving any questions. And Mick, small crowd on hand today, so we may not get any questions, but we'll hang on here for a few minutes. The next webinar, July 10th, buckle up. The future of the distributed database is here. DataStax's very own Robin Schumacher and Martin van Rijswijk will be presenting on that, and some exciting developments will be announced there. And then if you want to continue your Cassandra education, we have our free online Cassandra training. And then do not miss, are in the States, do not miss the Cassandra Summit 2014, which is in San Francisco on September 10th and 11th. And we have some certified training on day one, and then on day two, we have a fantastic agenda that we will be announcing actually later this week So make sure to check out the microsite on datastacks.com. Mick, are you able to make it over this year?
Not to San Francisco.
Will you be with us in beautiful, balmy London on December 3rd?
I will be. I have submitted my paper, and I hope I get accepted, and look forward to talking.
Brilliant. Yeah, saw that come through. And so if you are in Europe, no worries at all. The Cassandra Summit will come to Europe in the depths of winter because because why? Why not? So do we have any questions here? Let's have a look. So Mark, just one question right now, and that is from Marcus Moldashel. And he is asking, Mick, did you consider using MongoDB? So maybe you can address that directly, but then maybe talk about some of your criteria for selecting Cassandra.
Yes. So the selection of Cassandra was done when we started to write the statistics module that I talked about at the beginning of the presentation. And we did an evaluation of different distributed databases, but we were really only happy with Cassandra and HBase. They were the only two technologies which seemed to be doing things in the correct and the smart way. MongoDB is very easy to use initially. It has a strength as a document store. It didn't serve our use case, and we weren't confident about it when it comes to the questions of scalability and stability. When it came down to the decision between Cassandra and HBase, again, Cassandra suited that statistics use case a little bit better and had some more features. In hindsight, we are very thankful that we chose Cassandra. So over the last couple of years, Cassandra is a product that's just streamed forward and put more and more features out there and proven to be more and more robust. And so I think that today it's really a no-brainer. I hope that answers your question.
I'm sure it does. And Marcus, please send any follow-ups if you like. And Mick, what is the best way to kind of interact with you if people have follow-up questions? I know you're on Twitter. You had your Twitter handle up earlier. Is that the best way?
Yes, and I also had my email up, I believe.
Okay, brilliant. Maybe we can put that. Maybe we can put that back up for everyone right now.
Yep.
Can you do that, Paige? And then we will wrap up there today, Mick, and we'd love to have you back to present this maybe closer to the Cassandra Summit. And thank you again for being such a great supporter of the Cassandra community. We really, really appreciate it.
Thank you, Christian.
Okay, have a great evening, and thank you for joining us.
You too.